Hello everyone, this is Dr. Zach. So for today's lesson, I want you to focus on figuring out which method to use. Should you use the shell method or the disk washer method in order to find a volume? You should begin by graphing. We have y is equal to the square root of x. We know that the graph is bounded by x equals 0 and by y equals 0, as well as x equals 9. So the region that you see shaded in, we're going to rotate about the x-axis. So if we're spinning on the x-axis, that you cannot change. So let's write the word spin x. Now look at your equation. The equation is y equals square root of x. You could change that to x equals y squared. So it doesn't matter for this one which way you choose to do the problem. So let's look at the problem itself. If I do right minus left, I'm going to have to deal with a straight line and some curves. So that's not as easy, perhaps, if I were to do top minus bottom. And if I'm doing top minus bottom, that means I would prefer to use my x values. So if I'm spinning x using x, the formula is pi r squared for the area. So I need to know the radius, and that's the length of the green line that I've drawn, and the radius with respect to x is going to be square root x. So volume equals your pi integral. Our x values are going to be from 0 to 9, r squared, so that leaves x, and then the thickness is dx. So for each one of these problems, you want to choose depending on where you spin the equation and how to draw the lines. So here we have a reminder for your shell method. You're going to use 2 pi rh, whether or not you're using the vertical axis or the horizontal axis. It's always 2 pi rh for the area. The radius is perpendicular to the axis of revolution, and you should draw the radius from the center of the region to the axis, so some sort of arbitrary point. The height is always perpendicular to the radius. In words, if you're going to spin x, use y, or if you spin y, use x. If you choose to use the disk or washer method, you're going to use the formula for the area is pi r squared. You're going to draw the axis so that's perpendicular to the axis of revolution. Draw the radii from the edge of the region to the axis. In terms of words, spin x, use x. Spin y, use y. The washer method, you're going to need an outer radius as well as an inner radius, and you're going to draw the outer radius from the outer edge of the region to the axis, and the inner radius comes from the inner edge of the region to the axis as well. So now you have to decide disk method or shell method. So you have 4 minus e to the x. You probably want to use x's, but notice that we are spinning y, and I prefer to use x's. That's going to be the shell method, and the shell method means that we're going to use the area is 2 pi r h. So now that you've decided which method to use, the radius is drawn from the axis of the revolution to some arbitrary point. Notice the radius with respect to x is just x, and that the height is perpendicular. So the height with respect to x is going to be 4 minus e to the x minus 0, but that didn't matter. So volume is the area 2 pi integral from, well, what are those x values? Oh no, we're going to have to take 4 minus e to the x and set it equal to 0. So then we know that 4 equals e to the x, or the log of 4 is the x value that we're going to intersect. So we're going to 0 log 4 times the radius, which is x, the height, which is 4 minus e to the x dx, and once again, practice integrating with your calculator. So question number 2, disk method or shell method? All right, so look at this, people. Do you really want to solve this? I'm pretty sure I want to use x's, and I'm spinning on the y-axis. So spin y, use x. That's going to be a shall method, 2 pi r h. So what's the graph look like? If I put a 0 in for my x, then, oh, that's bad. You can't put a 0 in for x. If I put 1 in for x, I have 2 divided by, it looks like 3-ish, so 2/3. So 1 gives me about 2/3. Then if I put in 3, that's 2 divided by something a little bit smaller, so it went up. So this function is heading upward from 1 to 3. And it looks like we're using the y equals 0, so the region we're spinning is the one that I've shaded. Now, what do we know? I didn't say where we're spinning. Revolve the reason about the y-axis. There we go. So spinning y, and so when we draw the radius, that's going to be r of x equals x, and the height with respect to x is going to be the function 2 over 1 plus e to the 1 over x. So the volume is the area, 2 pi. We're going to integrate from 1 to 3. The radius is x. The height is 2 over 1 plus e to the 1 over x. And then we'll have a dx. Use your calculator and find that solution. All right, so number 3, as you can see, is actually asking you to find 3 different answers. I want you to hit pause, work these problems out, and then check your answer. Okay, so let's take a look. For the first question, you are spinning about that x-axis, and when you spin x, use x, that's pi r squared. For question B, for this one, you're spinning on that y-axis. Spin y, use x, that's your shall method. The radius with respect to x is going to be x, and the height is going to be your 10 over x squared. For question C, we've moved the axis of revolution to y equals 10. The outer radius is from where we are spinning to the outer edge. That length is going to be 10, and then when you look at the inner radius, see here, we're going to have 10 minus that curve. So big R of x is 10, little r of x is 10 minus 10 over x, which gives you a fabulous volume. So as you give number 5 a try, make certain that you set it up using the ideas that we worked with earlier. So give the multiple choice questions numbers 5 through 9 a try, and then look for the answers. All right, so the answers are shown. Now for your lesson follow-up, look at page 462 and give this problem set a good try. All right, guys, you have a fabulous day, and I'll see you during the next lesson.